Okay, today we're going to be doing an example on Lagrange multipliers. Now we're going to find the stationary points and also find their nature using Lagrange multipliers. Now, first step says find large f of x, y and lambda. Now what this means is we do this first equation, which is just f of x and y, plus g of x, which is our constraint, but with times g of x by lambda. So let's do that. So we've got x plus y all squared minus, because of this minus sign, lambda x cubed. Now our second step is to partially differentiate this function with respect to x, y and lambda. So firstly we're going to do with respect to x, and that will be using the chain rule. We're going to take this power down, and actually if we differentiate everything inside it just gets 1, so we'll be timesing by 1 on the end there, but that's useless, so we'll just leave it as 2 times x plus y. Then this is just usual power law, take down the 3, minus 1 from the power. Now here we'll differentiate with respect to y, do the same thing for the first part. However here we treat this x as a constant, so it just goes to 0. Remember actually to make all of these equal to 0. Then we'll do it with respect to lambda. Now everything else here in front is treated as a constant. Now we'll just have minus x cubed, which is equal to 0. So the third step would be to find the solution for x. So we'll be looking through each of these equations, seeing if we can get a solution to x. And there is one, quite simply. X is equal to 0 from this one. Now also from this one you can see that x is going to be equal to y. If we expand out the bracket, it'll be 2x plus 2y, sorry, minus x is equal to y, and then we minus the 2y over divide by 2 on both sides. So we have a stationary point at x equals 0, so that also means we have a stationary point at 0, 0. And to find the nature of this, we sub in 0, 0 into the original equation. So we get 0 plus 0, which just equals 0. And that would be a minimum point. Now, the reason this would be a minimum point is because I would think of this graphically. X plus y squared is sort of like a 3D parabola. So it goes like this, something like that. It's not exactly like that, but as you can see, there is going to be a bottom point here, and that is where we have x and y equal to 0. And because we know the constraint is minus x cubed, which is minus x cubed, what would that be? That would be something like this. Again, the only point that I can see where it'd be a stationary point is at this right here. So here we have another example, and we're going to follow the same 3-step rule really. 3.5 steps, it's the same thing. So first of all, we're going to find this big F function of x, y, and lambda, where we do f of x and y plus lambda times g of x and y. We really should change this over here to x and y. Now we use the same steps, partially differentiating. So here we'll have 1 plus 2 lambda x. If we just focus on this part here, because the rest of them are going to disappear, because they are treated as constants, then if we do with respect to y, 1 plus 2 lambda y, and then if we do with respect to lambda, we just get x squared plus y squared minus 1, because this would turn to 1. These would obviously disappear, and this would remain, whatever's inside the bracket. Now we make everything here equal to 0, of course. Now we can actually rearrange both of these equations here. Now the first one, I'm going to rearrange for x. So let's make it equal to minus 1 by taking 1 from both sides. Then we'll divide by 2 lambda. And we get minus 1 over 2 lambda equals x. And actually, can see that y is going to equal the same thing. So that must mean that x equals y. Now using that, we can sub it into here and get a solution for x. So that's 2x squared equals 1, x squared equals half, and then x equals plus or minus root half. So this must mean that we have two stationary points, one at x equals plus root half and at minus root half. But we've said up here that x must equal y. That's why we can't have 4 stationary points, you know, like alternating. So let's make them into coordinates. So it's easier to see. Now remember the third step. Actually, I'll bring this up here. The third step is sub it back into the original equation. So f of root half is root half plus root half, which equals root 2. And then we have minus root half minus root half. Same thing again. Minus root 2. So we can see that this is the larger one. So here we have a maximum. And here we have a minimum stationary point. Okay, here we have another example. We'll be doing the same thing for this one, following the steps and finding stationary points and their natures. So first step, find big F of x, y, and lambda. That will be 4 plus, x plus 4y plus lambda brackets 2x squared plus 3y squared minus 1 brackets. Now we will partially differentiate. So here we've got 1, treat the 4y as constant so it disappears, plus, just focusing on the x part, will be 2 lambda 2x. So actually we can change that to 4 lambda x, ignoring the rest of it, because you treat them as constants. Now we'll differentiate with respect to y. So we have 4, bring down the 2, so that's 6 lambda y. And now we'll differentiate with respect to lambda. And that just leaves us with 2x squared plus 3y squared minus 1. So remember that all equal to 0. Here, I can rearrange for x. So minus the 1 over and divide by the 4 lambda. We get minus 1 over 4 lambda. Here I will rearrange for y by minusing the 4 over and dividing by 6 lambda, and this actually cancels down a little bit to 2 over 3 lambda. Now, what I would do is try to make these denominators the same, so then we can compare them. So this one is going to be the same as minus 3 over 12 lambda, and this one is the same as minus 8 over 12 lambda. So to get from x to y here, we want to times by 8 and divide by 3. Because if we times by 8 over 3, if we times 3 by 8 over 3, these 3's are going to cancel and it'll just leave us with 8. So x times 8 over 3 equals y in this case. They both have minuses, so yeah, this would be one equation that we could use, and we can actually sub this one in to our last equation to get a value for x. So we've got 2x squared plus 3 times 8x over 3 all squared minus 1 equals 0. So first things first is get that 1 over, then we'll leave the 2x squared there for a moment. Then we'll leave the 3 outside, square that inside the bracket, so it's 64x over 9. And then we do 2x squared plus 64 times 3, 192. Oh, my bad. Forgot the squared there. That is a dodgy bracket. Okay, we'll have to deal with it. Now, to make it easier, I'll times by 9. So we can get 18x squared plus 192x squared. And then finally, we'll add them all up to get this. Then x squared equals 9 over 210. So x equals, let's just say plus or minus root 9 over 210. Okay. So here, we can sub this back into this equation here to find out what our values for y will be. So we'll get, 8 over 3 times root 9 over 210 equals, let me quickly get the calculator. 8 over 3 times root 9 over 210. Actually, it's better probably just to leave this. So we'll square root this. So you get 8 times 3, which is 24 on the top. And then we'll just leave the bottom. That's too much to deal with for me. Plus, that's not really what the point of the question is. It is to find the stationary points. Now, there are our two y values. So we have our stationary points of root 9 over 210, 24, 3, root 10, root 210, and root 9 over 210, sorry, with a minus, and then minus 24 over 3, root 210. Then finally, we will sub them into the original equation, which was x plus 4y. So we'll do x plus 4 times this y here equals, I already know there's going to be a positive number, but I will put it into the calculator. Okay, so it's getting me a decimal number, so it's not very nice, but it's something along that. But it's a positive number. Here we have, however, a negative number. Sorry, this is going to be a negative as well. So we'll just get the negative of the answer above. So this is going to be a maximum point, and this is going to be a minimum point.